Okay, so we left off on our homework quiz number 16 yesterday, and today we're going to go into wave calculations, all right? So our equation for wave calculations is going to be C equals lambda F, all right? Where C is the speed of light, which is always going to be 3.00 times 10 to the 8th meters per second. And I apologize on your printout. I don't think the 8 turned into a superscript. So that is times 10 to the 8th meters per second. Anytime you see a C, that is what you will plug it in. All electromagnetic radiation, all light, travels at the exact same speed, which is 3.00 times 10 to the 8th meters per second. Okay? Yesterday, we learned about the wavelength and the frequency of waves, right? This is our wavelength, this is our frequency, and they are inversely related, meaning if my wavelength increases, my frequency decreases. If my frequency increases, my wavelength decreases. So they go in opposite directions. They're like a teeter-totter, okay? Wavelength is, remember, our lambda, which is for the length. And in this case, we will use F for frequency. Frequency is always measured in hertz. Hertz is the same thing as having 1 per second, or, of course, it's like right there, second to the -1. It's not that I should hold you super accountable on the units, but I'm not going to. I just want you to be familiar in case you see those, you know what they are. Does that make sense to everybody? All right, perfect. Okay, so let's do a couple practice problems, shall we? I know that's what everyone wants to do. So we're going to do one example where we're solving for wavelength and one example where we're solving for frequency, okay? So, example number 1, what is the wavelength of blue light that has a frequency of 6.62 times 10 to the 14 hertz? So first thing we always do is write our equation that we're working with, right? Then we're going to write out our givens. Now, if you are somebody who struggles with math, I cannot overemphasize the importance of writing down your givens, okay? So we're going to write in here. Our first given is the frequency, right, which was given to us in the problem, is equal to 6.62 times 10 to the 14. So you should be writing these on your paper. Our next thing that we always know is which variable. Good. The speed of light is C is going to be 3.00 times 10 to the 8th, because that's always what C is going to equal. And of course, in this one, it's asking us to solve for what is the wavelength. So in this problem, we are trying to find this one. How can I get wavelength by itself? How can I isolate lambda? Divide by F. Okay, so if I divide by the frequency, these cancel out. And whatever I do to one side, you got to do to the other. Divide by F. So my wavelength is going to be equal to the speed of light divided by the frequency. Now I can plug in my givens, right? So my speed of light is 3.00 times 10 to the 8th over my frequency, which is 6.62 times 10 to the 14th. Now it is crucial when you are using scientific notation that we're using what inside our calculators? Parentheses. So make sure you have this in parentheses, divided by button, this in parentheses, in order to get your answer. And what did you guys come up with?
I did it wrong.
Let's see.
You put it in the
That's
All right, what did you guys get? Francisco, what'd you get? Can you put it in scientific notation? You should have gotten 4.53
okay.
times 10 to the negative 7, which is what it sounds like you got. So good job, Francisco. Remember, it's November. You should know how to use scientific notation on your calculator. If you don't, today is the last day I'm reminding you. You got to practice, 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 right? Use those parentheses. Use scientific notation. You have the psi button and the flow button, okay? Let's do our next example, which is going to be solving for frequency. Now on your paper, this is not the same problem because I wanted to make sure I gave you a frequency problem. So just cross out the word part and we'll solve for this one, okay? So solving for frequency, a bright yellow light is emitted from a sodium lamp. The wavelength of this light is 6.0 times 10 to the negative 7 meters. So first thing I'm going to do is start setting up my givens. This time I was given the wavelength, which is 6.0 times 10 to the negative 7 meters. Of course, I already know what's C going to be. Anyone? Good. And we're going to solve for our frequency. We always write our givens. Then we're going to write our equation where C equals lambda F. This time, we are trying to solve for frequency. So how am I going to get frequency by itself? I'm going to divide by, good, lambda. And whatever I do to one side, you got to do to the other. Very good. So my frequency is going to be C over wavelength. We can plug in those numbers where C is 3.00 times 10 to the 8th. My wavelength is 6.0 times 10 to the negative 7th. Now we're going to put that in our calculator in parentheses. Anyone? Layla? Atta girl. Should be 5.0 times 10 to the 14th power, and it's frequency, so our unit is hertz. So those are the two main types of calculations that we'll be doing. All right, that's it. You're either solving for wavelength or solving for frequency. Not too bad. There's a few more things I want to review for tomorrow's quiz to finish up the notes for today, and then we'll practice these calculations. Sound good? Alrighty. So remember, when we are solving for these wavelength and frequencies of light, why are we solving for them? Okay? The light that we're solving for is coming from the excited electron in the Bohr model, right? So when an electron is down here close to the nucleus, we call this the what state? The ground state. These are all things that you should have in your noggin by now, right? In order to jump up here to the next energy level, it has to do what? Absorb energy. Okay, so this is absorbing energy. And when it does that and it jumps up to the next shell, we call that the what state? Very good. This is not what we're seeing, okay? We do not see energy that's getting absorbed. We see it when it falls back down, and this energy is what? Released, okay? When the energy is released, we see it as light. And that light might be purple or red or orange or yellow or green, depending on the frequency of that light. So when you're solving for the frequency of the light in the wave calculation like we just did, you're trying to figure out what is the frequency of light being released by this electron in the Bohr model? That's how this all ties together, in theory. And if you don't believe me, just say, okay, Ms. Parker.
Okay, Ms. Parker.
Perfect. All right, here we go. So knowing everything we know, tying together frequency, wavelength, the light is coming out of an electron, okay? If these are all my electrons and these are my different energy levels, where the nucleus would be down here, okay? Which electron is most likely absorbing violet light? What do you guys think? A, B, C, or D? B. Very good. B is most likely absorbing violet light. Violet light has the highest amount of energy, right? When we looked at the spectrum yesterday, violet has the highest amount of energy. So which arrow is going up the most? B. So that's why it would be B. It's absorbing the most energy, so it's moving the furthest, and it's going up in energy level, so we know that energy is being absorbed. If that's the case, then which one of these would be releasing red light? C. Very good job, guys. Because releasing means the electron's going back down towards ground state, and red has the least amount of energy, so it has the smallest arrow. Does that kind of make sense to everybody? All right, perfect. So what color might D be? D could be green, I like it, or blue. Green or blue, probably. A might be what color? Yellow. Very good. Excellent work, guys. And remember, this is all based on our little acronym. What is it? Roy, G, Biv, where this end is low and this end is high. Okay, that's a review from yesterday's stuff. All right, just a little refresher on these in case you see them on a quiz or a test. Probably the test. Okay? If this is my emission spectra, right, every element has its own signature fingerprint of light, and that is my star spectrum. What elements is my star made up of? What do you guys think? Good. I would definitely say helium's in there. Let's look at helium. Here are my lines for helium. If I look at my star, this line, this line, this line, this line, and these two all match. So I would say helium is a match. What's my other match? Hydrogen. Very good. So hydrogen's right here. We have this 4 lines, and you can see those 4 lines show up right in there. So this star would be made up of hydrogen and helium. And just so you know, they love these on the state test when you take that later on. I don't know why, but they really love them. All right. All that being said, let's summarize this. So these colors, bless you, that Bohr was observing was from electrons dropping from excited state back to ground state. They release the energy as a photon or a light wave, and we can figure out what color that light wave will be using the wave calculations we learned today. All right. This is what your assignment looks like for today. Okay. You are going to show all work. You got to show me the work. You got to show me where the numbers are going in order to earn credit. A couple of things in order to head off some questions to start. If you are struggling with math still, if you still struggle with the algebra rearranging of the letters, you can still use the little triangle trick, okay, where you go like this, and the speed of light is equal to wavelength times frequency. All right, if you hide whatever variable you are looking for example, if I'm looking for wavelength, I'm going to do light divided by frequency. Does that make sense to you guys? If I'm looking for frequency, I'm going to do speed of light divided by wavelength. Okay, so you can use this little triangle to help you come up with all 3 equations. The third one being C equals wavelength times frequency, so you can rearrange for the other two. You need a frequency one, and you need a wavelength one. Does that make sense to everybody? Perfect. The other thing I noticed is we're forgetting some of our math fluency skills, okay? So, for example, on the worksheet, some of them are written this way, and some of them are written this way. 9.90E2 is the same as saying 9.90 times 10 to the second. That little e means the same thing as times 10 to the. It's just another way to write it, okay? So when you see it in there, don't let it surprise you or scare you. It just means times 10 to the. Are we good with that? Yep. Now, conveniently, to make sure that you're getting these right so you're not practicing them wrong, because that would suck, I have posted this as well, and I will leave it up here for you. These are the answers so that you can check your work once you've gotten it on your paper, okay? I just rounded everything to 2 decimal places, if that helps you out. Cool? All right, guys, go ahead and get started on this assignment.